How does an internal combustion engine work? Today, we're going to look at the working principle of ICE and take a look at the most important steps of its operation that make the engine turn the wheels of a car. On this channel, I try to explain things in simplest ways for people like myself so that they understand and learn together with me. Join me on this journey and let's learn together. I am not going to bore you with the history of the creation of ICE, so let's get right into it. An internal combustion engine, or ICE as I called it earlier, is an engine in which the combustion of fuel occurs with an oxidizer, usually air, in a combustion blah 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 blah. Simply put, an internal combustion engine is the engine that works on heat and pressure generated from burning the fuel. Now, let's imagine there is a guy. Let's name that guy Andy. Andy's a chill dude. Now, let's put a giant dynamite right next to him. What happens to Andy when we ignite the dynamite and it explodes? He is pushed away because of the energy wave that the explosion generates. Now imagine the same thing happening in a small chamber, but instead of Andy, the explosion moves the pistons. That is the very basic and extremely simplified principle of the ICE. But let's take a closer look. Most car engines are four-step engines. The four steps are intake, compression, power and exhaust. All of those four steps take place right here inside the engine. Let's look at each of these steps. During the intake step, the intake valve opens and the piston moves down the cylinder, allowing a mixture of air and fuel to enter the combustion chamber. Next, the intake valve closes and the piston moves back up the cylinder, compressing the mixture. This makes it easier to ignite and more powerful when it combusts. And now, here's where the magic happens. The spark plug ignites the compressed air-fuel mixture, causing a small explosion. This explosion pushes the piston back down. Finally, the exhaust valve opens and the piston moves back up again, pushing the burnt gases out of the cylinder through the exhaust valve, thus concluding the up and down motion cycle of the piston. This whole process can happen very quickly. In a typical car engine, it can happen hundreds of times per minute. The bigger amount of pistons provides a bigger overlap between each pump of a piston, which provides a significant increase in performance. However, due to the fact that bigger amount of fuel is burned in that type of setting, the fuel efficiency of the engine drops. That is why, in the cars that focus on spending less amount of fuel per kilometer, the engines are built with a focus on fuel efficiency rather than the power of the engine, while the sports cars and trucks focus on the power and torque. Now, you might actually take a look at the older ICE versions and see that they have their pistons arranged in one line, which is why they are called 2, 4, 6 or 8 inline engines with the number that comes in front of it indicating the number of pistons inside the engine. However, the more modern versions have their pistons located in a V-shaped position, which is why they are called V-type engines. That design has been chosen deliberately due to the fact that locating bigger amounts of pistons in a single line would cause the engine to have an enormous size. The V-shape allows the positioning of the pistons in such a way that the design turns out to be smaller and more compact, which helps the engine to be fit in cars with limited space and also helps with the optimization of the engine efficiency. Now, you might be wondering, how does the power from the pistons actually get to the wheels? Let's take a look at that. When the piston is pushed down by the explosion in the chamber, it moves a connecting rod. This rod is attached to a crankshaft. As the pistons move up and down, they turn the crankshaft, which converts the up and down motion into a rotating motion. Next, the rotating motion of the crankshaft is transferred to the transmission. The transmission controls the power and speed of the vehicle by adjusting the gear ratios. It's like a big gear system but slightly more complex. There is a wonderful video from 1937 which explains the concept of a transmission in a very simple and understandable way. So I will leave the link down in the description, please check it out, it is actually amazing. Now from the transmission, the power goes to the drive shaft. The drive shaft is a long rod that transfers the rotating motion to the differential, which is a set of gears that distributes the power to the wheels, allowing them to turn. Finally, the differential transfers the power to the axles connected to the wheels, making the wheels spin and moving the car forward. And that is how the power generated in the engine's combustion chamber ends up turning your car's wheels. I hope you found this explanation helpful. If you did, please like this video and subscribe to this channel for more fun and easy to understand explanations of how things work. Now, before we finish, I would like to mention the fact that this is my first video on this channel and I would really appreciate your help and feedback in the comments. Let me know what you would like to see me explain in the next video. Thanks for watching and see you next time.